Okay, so without further ado, let's just dive into it. I will try to explain on how I usually approach light, value, and colors, because I think this is the most fundamental things before we apply colors and how we control value depending on the colors. And for me, this is the most difficult task to do because I usually have to understand the very basic fundamentals or knowledge or theory or even the science behind how the lights are behave that way or how colors are behaving that way. Here are some examples of my own drawings, of my own understanding about how these likes, value, and colors are synergizing to each other. And by any means, this is the most basic explanation because in the more advanced topics, that will be then how to compose this lightning, how to create those the right combination on how to create a contrast between the colors and such. There is a lot of more color theory out there, but for this moment, for this art sharing session, for this video right now, is I wanted to show you how the basic things are working. And these basic fundamentals are not by any means are easy as well because there is a lot of things to understand. A lot of people are probably thinking like, oh, this is an easier thing to do because, well, yes, it can be easily done by some people, but for people like me, I had to understand how the fundamental science and how it behave in nature that are is it calculated and such, so I could make an educated guess, and then by an observation I could improve towards that. For now, this is the my own drawing that are trying a little to explain what's going in my head when I try to make a lightning, a value, and colors. And I will try to. There is some image that are shared by the Feng design that are really interesting on how he approached this color scientifically, but in a simple manners. But for now, let's go into what's how do I approach lightning, value, and colors first. The thing that we need to understand is that lightnings is coming from the source, the lightning source. And this lightning source creating a particle of lights. Particle of lights that are pushing through. It can be light particle, radiation, or an energy even to go through this a space. Either there is an air in space or even in water, and it will reflect on the objects, and we as the camera will receive red lights. And how do we determine these lights and how bright, how dark those lightnings are going through our eyes? For this simple object, these simple circle objects, for example, is that if this is the light source, there is what we call the Lamberts Emission Law, which is if a light source is directly giving the lights to an object directly in a 0-degree manner, it will reflect back at least at the same power, depend on the materials and the light and the colors of the objects. And if it's more a little bit diagonals, the lights, for example, this is the 45 degrees. According to these diagrams, let me zoom it a little bit. According to these diagrams, in the 54, we will get still a very bright lights through our, because there is still a lot of lights that are reflected in even reflected back about 80 or 90%. If we compare it to the direct object, if our eyes here, if the light from it will reflect back in 100%. If it's 45 degree, there is still some of this energy, even though there is some are reflected back, reflected to the other side of the objects. It's still, there is some of them that are reflecting back, and it's still very powerful in a 90%. So for in these objects, if we are seeing from the front, if there is the lightning source, if it's directly in front of us, it will press 100%. And if it's on the other side, about maybe 45 degrees in the circle, there is still 90%. And if it's on the, or maybe 80%, it's already dropped to 48. So in this side of the terminal lines, there is a certain lightning anatomy. Let me search for the example of that. The terminator. The terminator is what, like in this 80% going to 90%. And after this 90%, light will pass through them. So in this kind of situation is that after we understand this, it's like if we want to approach lightning, we have to see that there will be a difference in this value, even though we giving this light directly to an object, it will reflect back in a different manner depending on the angles of the object itself. That's how lights are reflected. So the way how our eyes are capturing an object lightning, it will be a very different, it will be giving a different brightness or density in an object. So that's the first one about the lightning and how the basic of the emission of how our eyes are capturing the particles from the object and how the lights are reflected from an object. And this is the kind of how usually lights are behaving. For example, if there is a direct, there is two types of lightning. That's the direct lightning and reflected lightning. And for this disclaimer, the term that I will be using might be a little bit different from the other resources, since I'm not really remember all of them yet, but at least this is what the general terms that are going to be used in this video. And for this example right now is of this object in the marine colors, and in this direct lightning, and it will reflect back to our eyes. And we can see as well if there is another source of lightning. Depending on how strong the first lightning and the second lightning is, it will give different colors to these objects. As we understand that if this yellow lightning and this object is emission is the red in a red spectrums. Sorry. In the red spectrums. And if there is a yellow lights are added to these objects, it will, in the strongest area, it will become the most reflected, the yellow, depending on the how many or how glossy the object is. But in the side of the other and the gradients, it will become an orange because of a red, this yellow. It will become orange in the sense of how this spectrum of lights are happening. So for the second one is the reflected lights, and what we always remember, this is also the third source. Maybe in this scenario, this is the third source of lightning itself. But what we need to understand is that the reflected light, depending on the objects behind it and how far and how close, it will affect more on the how these reflected lights are behaving. The more, the further the object is, this background is, the less intense the lightning. So if we wanted, and in this case, it's the same case for these backgrounds in the floor. It can also reflect it back to adding more lights into the object. And this intensity, the intensity different. For example, if this is a 40%, 50%, this is not mark color. This is red in a very low light condition. Just imagine in this scene without this one. And this is in 50%, and this is 100% of light source. And this is a very relative, because our eyes will adjust depending on how those lights are captured. And the eye have our iris as a diaphragm, and it will control on how much lights are going to our eyes. So it will vary. It will varies in a difference in the how intensity of the lightning are. So for example, this is the maroon because of there's less light, because there is less color to be emission to the environment, and these have more particles to release to the environment. And how this is how this will affect the values, this is way far more darker than in this one. So, and then and by that one, we can say that the value will depend on how the lightning are. This is, for example, this is the highest value, this is the second value, the third value, and this is the fourth value, and this is the fifth value. It usually I approach this on certain condition. For example, in this situation, let's jump into the value. We already understand that the lightning are affecting how the object reflected light behave. So for example, if this is an object. For example, this is without any lightning, or this is the most, this is the base color of the objects. In the condition without lights, it's pure dark. We have no idea. We have no value difference between the objects. But if we add more lightning to the environment, and this is the ambient colors, ambient lightning, sorry, in ambient lightning, which is how much lightning from the outside, maybe from the sky, from the floor, or even from the ceiling, from the wall, are affecting the much of how many ambient colors are there. And it can be source of the second lightning, but usually it's not. And the more lightning there are, the lightest the objects are. For example, in this white condition, in the white room, there is much of this lighting. It will give a lot of energy to these rocks and reflect back to our eyes. And so this is how it will look like if there is a lightning coming through from the direct sources of the lights. And this is how much of the darkness of the ambient colors that reflecting on the shading. And the shading, sometimes there is also some more shading in the objects, depending on how the occlusion works and such. So it will create a value usually for easier approach to determine value. We have to at least determine 5 values, so we don't scatter, we don't confuse in how to approach things. For example, if this is a circle, just make sure if there is different values for 2 values at least. This is the highlights. And this is the halftones, and this is the shading. This is the shadows and ambient occlusions, and maybe some reflect lights. So at least we have to remember that this reflected light must not brighter than the halftones. And this is how we should simplify those values. So back to how those values work. In these colors have an init value. For example, it's right here. The value of red is more darker than the yellow, which is the yellow have a very likes value, inner value, very light inner value compared to the red, compared to the green. So we can in the spectrums of the colors, our eyes captures this yellow, this cyan, and this magenta as somewhat unlike very light lighting, but in reality this color value are the same in the sense of technical values. For example, if we change the saturation of these colors, it will turn into grayscales. All of them are the same value, the calculated value. Yes, they are all the same. But if we are taking into account how these lightning have their own inner value, this would be it. So how to remember these kind of colors that we can see them in the Munsell color system. In this Munsell color system is that every color have their own value sets. For example, in this yellow part, this yellow is on the white side of the value in 3. And if we see them on the magenta, it's the value of the 50%. If we the chroma of the colors would be the in this magenta would be in 5 or 6, 5, 6, 7. This is almost in the middle of the value. So in a sense, there is a relative difference in the value, even though their hue is the same. The chroma is well, there is a different power of the chroma, but in the calculated saturation, the hue are in the same value in the 50%, but they are way much more lighter. And you can find it in online resources that this kind of palettes of the Munsell system. We can see that yellow having a lot of the maximum hue, the maximum saturation of yellow the value is it's very like. So if we want in an illustration, we want a highlight, but with a very vibrant colors and a very vibrant chroma, we can choose yellow as the highlight, even though yellow is a 50% value, a 50% gray, and 100% of white, and 0 is black. So for example, in the violet and the purple, the most the maximum chroma it can be achieved in the very darker value. So if we wanted an object to be more darker in a very light condition, we can apply this color. For example, in the setting of a very bright in the afternoon, if we want to create a difference in the color value, we can choose a violet. It will give an object a more darker value. So this is what I learned from the internet about how light, value, and colors are behaving. And for the next one is that I found a really interesting approach by the Feng Shui design. This is for Feng Shui design. I will put the link in the description in the comments. So, what in the Feng Shui approach is basically how the lights are behaving, and he's simplified in a simple manner. So in this one, I will try to explain more about what this Feng Shui design explanation about how the lights are working. So in this particular sets of drawing that I will put the link to the Feng Shui Design's Twitter, and I will just talk about how the lightning works, because there is also he's also explaining about how the composition work and how the choosing of the colors, how the warm and the cool colors are working together in the condition. You can see that you can try to understand them in the Twitter of the Feng Shui design, but for now I will try to explain how this is very incredible simplified explanation about how lightning behave in our world. So the first one that he tried to that I in this situation I will try to explain what I understand in this set of drawings. The first one is that he is explaining how these light particles are working in either vacuum condition in the space and in our real world. So in this drawing, for example, this is the light source are pushing through in the vacuums. There is no air particles, there is no water particles or any other particles that are going to reflect back or scatter the lights. So in the vacuums, if it hits an object and these objects are able to reflect back the light, it will reflect back the lights without being scattered, or being diffused by some materials. If it's came from up, it will strike them back and such. So the energy is not being reflected or deflected back by the scattering because of molecules or materials in the air. So this is the eye of the. This is the light source, and this is the eye of the receivers. So if there's light, there's only the light back. Maybe some from here. We can see them here as well. It's depend. So in this, the second set is that in the real world, this is from the sun. For example, this is for the sun. The sun going from vacuums to our atmosphere. And in our atmosphere, we have water, we have oxygen, we have nitrogen, we have CO2, or any carbon compound, or even other things, even the sky, even the clouds that are forming. And these materials will reflect it, and it will scatter the lights from the sun. For example, if the light of the sun are coming from the sky, because of these particles of maybe any molecules, it will scatter. Let me zoom it out a little bit. It will scatter to the light will scatter, because why do these light are scattered? For example, this is how if the lights are going through an object, it maybe can pass through, but due to some materials components, it can be scattered, depending on how big and how thick and how transparent the objects are. And that's how light behave. If there is an object, if there is a molecules, it will scatter. It will scatter, and sometimes it's reflected back to our eyes. So in the real world, because of this condition of there is a lot of molecules, when the lights are passing through this air, when it's going back, it will scatter, or maybe they are not even approach to these objects, but they are already being scattered around and reflected by these molecules in the air. So it will create what we call an interference. This interference will cause this, for example, this is a very bright objects. This interference might decrease the saturation or the value as well, or even increasing or not increasing. Usually it's decreasing the saturation and the value. So by that we can understand that there will be scattering, and this is very important. For example, if we stand in the 1 meter of an object, if we stand in 1 meter of an object, it will reflect back, and less particles are interfering with the lights that are coming back, or the lights that are going through the objects. If this is far away, the lights there's a lot of interference. There is a lot of interference that before the lights approaching the object and reflected back in our eyes. So that's how the scattering are working, how the lights are scattered in real world. So this is the example. If this object is a black object, if this is the direct lights, and if we see them in our eyes in the 50 meters, less particles are there. This is how we see the object is. This is a very, very dark value. But if we see these objects, there is additional materials are in our way. The lights are scattered before it reach the objects, and it creating this interference or disturbance. It will drop in value depending on how the lights are working. What kind of colors the lights are, it will decrease the value depending on the lights. For example, if this is a white light, it will decrease and it will become into gray. And the farther the eye see in the objects, the more materials they are scattering the lights back to our eyes. And it's in a farther condition, it appear more dense because in our eye there is an angles, these perspective angles that are happening. For example, if in a close enough, it will be 3, and in the very very far, it becomes 300 of interference. So it will make the colors appear more. The value is increasing because of there is more lights that comes through our eye, and also the saturation is decreasing because of this interference by the external lights. They are trying to get there, but it's because of these particles that are reflected back, the saturation is decreased. This is the same example with reds. The closer they are, the more vibrant they are. And of course, there is another factors of how these molecules and molecules in the air are affecting the saturation. For example, in the very foggy situation, even if in the 50 meters, we cannot see anything. And also, this is how, if there is blue colors, how it behaves in the blue colors. This is this is the Feng Shui when trying to take on the warm and cool colors. There's theory about that, but we will not touching that yet. In the first sets is that how the lights are behaving in the nature. So and then how the light are behaving and scattered in the real world. Light also have the spectrums. In this kind of situation is that the lights have their own nanometers of the light waves, and this is the low waves. And if we are in the prism is a perfect example of how this how light being scattered by this prism and create a different wavelength of colors. This is the red. The red is the very white, have a very low power, and then this is the ultraviolets. This have a lot of a stronger wave, and this will affect our eyes. Our eyes are only able to see this light spectrum, the visible spectrum of the human, as we learn in science. So this is the weak colors, and this is the strong colors, depending on how the spectrum are working. And in our human eye, we perceive them as the red, green, blue. For it's in the RGB of the colors. If we see the monitors of the 25, the maximum numbers, and the green of 25. And it will create a different combination. If this is R combined, it will become yellow and such. So for example, if this one is combined, it becomes the violet and such. And if this is green and blue, it will become kind of bit cyan. So it will vary depending on those. And this is how the color grids are working and such. So, and this is how this is how values are perceived mathematically. The value is always 10 to 0, 10 and 0, and it's depend on the lights and how we will approach them. And a human range will always have the limits on how our eyes are perceiving those lights. And this is what we call that, like the first one that I explained in the first in my drawing, is that there's these primary lights that are coming from either lights, the fire, or anything that's our primary going through the objects. And then there is a secondary lights, or maybe different, maybe ambient lighting or reflected lights that are from the floor, from the from the uh, from the sky, or any ambient lights are coming from the other side. If this is the primary, and this is the secondary, and this is the primary, and if it's deflected, or from the other side, is the secondary. And this is the ambient occlusion. If there is no lights, this is the lights, and this is the secondary lights. But if the secondary lights cannot approach this section of the objects, it will create the ambient occlusions. And this is how the particles are working. Like, if the lights are approaching in these objects, it will not just reflect it back depending on the lightning. It can be very scattered. The emission is going everywhere, because the light source is not only one. It's usually one directional, but there is a lot of things to be considered in the reflection of the lights. So because of this condition, like we can see, is that it's depending on the eye as well. The location, it can appear more bright because of there is a lot of light source that are approaching to our eyes, and it's depending on how dense these light particles are being approached. And there is a lot. I will put some resources on how this light are working, and it might help. Even though this is a very complex thing to talk, but if we understand at least a very basic, getting the sense and the gist of the color, we can create an educated guess, and we can absorb more from the references that we are going to analyze. So with this basic theory, we can in the further learning, we can try to grasp more information from maybe paintings, maybe photos, or maybe another objects that we want to observe, and we can absorb more because of we understand what things that we need to see of those learning objects. There's also what we call this is the surface scattering. Surface always scatters, and this is the subsurface scattering. In certain objects, after the first scatters, sometimes the objects are going to inside of these objects, and it can scatter around these layers, and layers are emitting light too. For example, in the skin, we can get these subtle, even though the skin is colored maybe a little bit yellowish, or even dark color, brown, and that will always have these reddish tint, or not a tint, or a reddish colors that appears from the surface below, because of the subsurface scattering that below our skin, below our pigments, there is blood vessels. They are red. So what we are learning is that there's a lot of things that we can learn from these objects, and you can read it, and how this composition are working, and how our eye are what is it called, are perceiving those lights, and how its colors, because of how our eye work, it will create a sense of different value in each colors. So in this third picture, it's about how approaching of these cool and warm, how we perceive of those blues are very strong colors, and red is very weak, and red as a weak colors because of this wavelength and such. And this is the example that the FCD are showing how the scattering in this, for example, like in this illustration, This is the atmosphere scattering in the sky, maybe in the pollution and such. And this is the subsurface scattering that certain objects will emit a lot of different colors, and we can adjust them depending on what colors are inside. So for example, if an object is a green, the spectrum of colors, the leaf will absorb any colors except the green. So how these objects are green? Because they are reflecting green. So this is how the theory of how the scattering are working, as we see in this far object, because of there is a lot of water molecules, air molecules in the air, and the density from the far away, the density are more complex. We can see that this value is about gray. And this is the maximum of the shadow in the far away, and this is the closer one. If we look, the dark the dark value is a little bit more darker, and it have more saturation. And depending on the lights and the atmosphere, it will cause a different saturation in the objects. This is how it's far and how, so we can play with a lot of different saturation and different, but we have to understand that the object here should be having more saturation, either more value range compared to these sides, or even this side and in this side as well. So it will come back to this how you would compose these illustrations, and this is how maybe in a foggy condition we can see that in this area the maximum values of shadows are decreasing, and this is more darker values. This is far, this is the most darkest value, and this is the most dark value here. This is the most darker value there. So it's the further away, the less saturation they are, and it's become more lighter because there's more lights are coming through our eyes from the sky, from the air around them. So for example, this also affects to so this is affecting on how our eye should perceive those values. In the far away condition, we limit our value maybe around here because there's a lot of lights. Even the shading, the shadow, this is the highlights, this is the midtones. The most shaded area will be in this condition. Maybe for example, it's the 100 meters. So in the more closest area, we can add more value to those. We can add more range value to those objects. This is the highlight, the midtones, and the shading. And the closest object we have, we can set them as far as our human eye could possibly have, maybe in 10 meters. So it giving more details compared to what we see in the far away because of the scattering and interference and such. And also, you need to remember that every color have their own power due to the spectrums, how the spectrums are working. Red is darker, the yellow is more lighter, approaching more lighter in our eyes. The blue, the magenta is more darker. It's there is a lot of there is a different theory about how sensitive our eyes are depending on what color. I guess it's depending on how powerful our eyes are getting this chromas out of these colors. So maybe that's it. If there is anything that you want to discuss or you want to ask or even want to share, you can put it down on the comment below, and I will put the resource down there as well. If there is, this is not by any means the right things to do. This is how I perceive. This is what I understand, and this is what I have learned. If there is anything that you want to add or you want to change, or if you have a correction on how should I approach this kind of colors, value, and lightning, you can also discuss in the comment section below. So that's for today. Hope you have a nice day and keep practicing.